Hi everyone. Today we're continuing to solve inequalities, but what we're really going to be focusing on here, the new piece, is translating sentences into inequalities before we solve and graph. So much like we did when we were solving equations, we're going to have to be looking out for particular keywords to help us translate from words into algebraic symbols, and then we'll solve and graph. So first we're just going to do a quick review of some keywords that you might see in these problems and what symbols go along with them. So when we see the words is less than, we know we're going to use our inequality symbol for less than. Is greater than will look like that. Less than or equal to, we're going to take our less than and add the line underneath. And then same thing for is greater than or equal to. Now those are really straightforward. Here's where we might have to think a little bit more. So for the first one here, is no more than. So we have to think, this is saying is no more than. It can't be greater than a certain number. So this is actually, if a number is no more, let's say I said the number I'm thinking of is no more than 10. Means it has to be less than or equal to 10. I could pick 9, but I couldn't pick the number 11 because it is more than. Is no less than, then on the other hand, has to be greater than or equal to. Let's see. Is at most. So is at most is going to be less than or equal to. And then is at least is going to be greater than or equal to. So let's look at some sentences and work on translating. Now, not only are we going to have to be looking out for these inequality symbols, we're also going to have to be looking out for keywords that tell us the operation in our problem. So we won't go through all 8 examples likely, but I'll pick and choose some to go over here. So let's look at number 1. So we're going to write the sentence as an inequality, then we're going to solve the inequality and graph the solution. So the first thing I see here, I see the sum. I know sum is my keyword for addition. So I'm taking the sum of 15 and n, and then I see is less than. I know that's my inequality symbol, and it tells me it's less than 8. So let's see, I'm taking the sum of 15 and n. So that's telling me to add 15 plus n is less than, and then I have my value 8. Okay, number 2, let's see, it says negative 3 is greater than. When I see that, I know I have my inequality symbol. Then if I keep reading, it's greater than the difference. I know that difference is subtraction, and I have the difference of x and 7. So going from left to right, I have negative 3 is greater than, and I know I'm taking the difference of x and 7, which is x minus 7. Oh, I guess I need to go back here. I forgot to solve and graph these. So let me back up to number 1. So if I were going to solve number 1, I'm solving it for n. I need to get n all by itself, so I'm going to subtract 15 from both sides. That's going to cancel, and I'm going to have n is less than a negative 7. So I'm going to find negative 7. Since it's strictly less than, I have an open circle, and that inequality symbol is telling me that I can shade to the left. So that's what I'm going to do. And again, I put the arrow at the end to show that that continues forever. All right, number 2. Let's see if I'm going to solve. Now my variable's on the right. So to get the variable by itself, I'm going to add 7 to both sides. So negative 7 plus 7 is 0. So I have x. I copy the same inequality symbol, and negative 3 plus 7 gives me a positive 4. Now, before I graph this, I'm going to rewrite it because I want the variable first. So we're going to rewrite because I want the variable and then the number. Now, the pointy end was pointing to the x, so when I rewrite it, it has to look the same. So now my inequality is x is less than 4, and my arrow is telling me to point to the left. I'm an open circle at positive 4, and I'm shading left. All right, let's skip 3 and 4. Let's go ahead over to 5. All right, so the sum of 4x and 7. So I notice here I have the sum, which is going to be addition. So sum of 4x and 7 is no more than 39. So it cannot be greater than 39. So we know this is less than or equal to. So if I translate here, I'm adding 4x and 7. So I have 4x plus 7 is less than or equal to 39. Okay, we'll do our usual steps to solve. I'm going to subtract 7 from both sides first. So this cancels and I'm left with 4x. My symbol stays the same because I just subtracted there. 39 minus 7 is 32. Now to get the x by itself, I'm going to divide by 4. Since I divided by a positive, my symbol does not change, and I have x is less than or equal to 8. Again, because my variable's first, it tells me to shade to the left. Now this time, since it's less than or equal to, I have a closed circle on 8, and I'm shading to the left, just like we have for the others. Okay, let's see, what do I want to do? Let's do number 6, and then we'll pick one more. All right, so the sum of 5x and 8x, again, sum is going to be addition. So sum of 5x and 8x is no less than. So no less than. So it means it has to either be greater than or equal to the sum of 4x and 27. So let's see what we've got. So first I'm doing the sum of 5x and 8x. That tells me it's no less than. So has to be greater than or equal to the, oh, I forgot this keyword here, the sum again of 4x and 27. So now I have 4x plus 27. So there's step 1, my translation. So now I have to simplify before I can solve. Well, the first thing I notice here is that I have like terms on the left side. So I'm going to go ahead and combine those. So that gives me 13x is greater than or equal to 4x plus 27. Now I've got variables on both sides. I want all my variables on the left side. So I'm going to subtract 4x from both sides. And I have 9x is greater than or equal to 27. So the last thing I'm going to do is divide by 9. Since I'm dividing by a positive, my inequality symbol doesn't change. So I have x is greater than or equal to 3. So my arrow tells me I'm going to shade right. I have greater than or equal to, so I'm going to have a closed circle on 3 and shade to the right. All right. Let's do number 7, and then that'll be good for the video. All right, let's see. I have the quotient of a number and 2. I know that's division. Quotient of a number 2 is at most 16. So the most it can be a 16, which means it better be less than or equal to 16. So let's translate. Now remember, for quotient, the order is important. So since n comes first, n is going to be on top. So I have n divided by 2. And they're telling me is less than or equal to, let's see, we're going to have to change this number here because otherwise it's not going to fit. So let's say it's at most 5. So n divided by 2 is less than or equal to 5. So now to solve, here I have division. I know the opposite of division is multiplying. So I'm going to multiply by 2 on both sides. On the left side, my 2's are going to cancel, and I'm going to have n is less than or equal to 10. Again, my variable's first, so my arrow tells me to shade left. So I'll have a closed circle on 10, and I'm going to shade to the left. All right, so right after you finish this video, you'll get some practice to make sure we've got this translating piece down. All right, thanks.